I'm going to talk about more the relationship between the Toyota Way and Kata. As you might see the word second edition in the Toyota Way, I completely revised the Toyota Way after 17 years, and it continued to sell well for 17 years. But I really felt something was missing that I needed to add, and that was really based on learning from Mike about Toyota Kata, and that was the concept of scientific thinking. And Toyota Kata really is about developing a mindset and a way of thinking. Now, if you look at the history of lean, there was a point in the 1980s where it was viewed as a toolkit, and the big thing was just in time. And how can we bring material into the factory and then to the customer with as little inventory as possible? And that was sort of like the goal, like a race against time to try to reduce inventory. I had learned from Toyota that it was much more than that. And it was really a total look at the value stream from raw material to the customer, starting with the customer, and then trying to develop and deliver products that the customer wants and needs when they want it in the amount they want. And every part of the enterprise really is geared toward doing that. The term lean thinking then came up in a book called Lean Thinking by Jim Womack and Dan Jones. And they said, this isn't really a methodology. It's not a set of tools. It's a way of thinking. And the way of thinking was largely that enterprise value stream view and then shrinking lead time. And it was really Mike's Toyota Kata that clarified for me that the way of thinking is really something even more fundamental, which is scientific thinking. And we'll be talking about that. First, starting with Toyota and their version of the Toyota Way, which I was able to study before I wrote the original Toyota Way. And they just describe it as the whole company revolves around two pillars: continuous improvement and respect for people. And for Toyota, respect for people is more than treating them fairly and treating them nicely, which is certainly part of it, but it's challenging them to grow. It's developing people. It's making people the best they can be. So investing in developing people is really central to Toyota, and they do more of it than any other company I know. For example, if you are hired in to product development as an engineer, for the first year, you're just getting generic training in how to be an engineer, what the Toyota production system is, and you get immersed into things like selling cars at a dealership. And then you work on a project with a mentor, and in year two, you're a freshman, you're working on some specific project with a mentor, and then you work on a product development program. But by the time they say you're really an engineer, it takes about 6 years. So it takes longer to become an engineer in Toyota than it does to get your university degree. And they consider the university degree a starting point of creating good raw material. Continuous improvement is a philosophy that says that even if we want a breakthrough, like today, the future of mobility with self-driving cars and electric vehicles, we're going to achieve that breakthrough through many small steps. Continuously meaning that we level out the thinking and the planning and the doing. So we're doing something every day and not waiting for big milestones and then cramming before the test. And that something could be transformational for the whole company, led by the very top of the company. It could be led by middle management, for example, in a plant, in a department, or it could be on the front line, a group leader, team leader, and team members who have processes that they're trying to achieve targets for productivity, for quality, for safety. In every case, they're using the same way of thinking, the same meta approach to improvement, which Mike called scientific thinking, which is shown in the foundation of the Toyota Way. So the three elements that support continuous improvement are: first, challenge, which is having a clear direction, a clear purpose, and knowing why you're doing something and what you're trying to achieve within a time frame. Usually the challenges in Toyota are on an annual basis, and they have a process of Hoshinkanri, of deploying goals annually that set the challenge for everybody at all levels. And then when you have the challenge, you just know the direction. The immediate first step should be, where am I now? And they do that through going and seeing at what's called the Gemba, which is where the action is, where the work is being done, where the product is being used. So you go and you see and you observe directly and learn, and they place a high value on using all your senses to understand the current condition, not only statistics and data. And then you Kaizen. And Kaizen is often discussed as plan, do, check, act in the terms of Dr. Deming. And that is, you run experiments. You try it, you plan something, you try it, you check what happened, you reflect on what you learned, and then you do it again, and you do it again, and do it again toward in the direction of the challenge. So collectively, this is continuous improvement at Toyota, which happens to look a lot like the improvement kata that Mike developed. And it's not a coincidence, because Mike developed it first by studying Toyota, and particularly the master trainers of the Toyota production system within Toyota. So I revised the Toyota Way model. Originally, it was the 4 things you see, the 4 P's I called it, and it was a pyramid. And instead, I made it an interconnected system, but put scientific thinking in the center. And the starting point of scientific thinking is the philosophy. Toyota is always thinking long term, where we want to be in 2050, and 2035, and 2025. And they are thinking in system terms. So the Toyota production system, probably the most important word in that is system. So they will say doing one thing, like installing a Kanban system, so you're pulling inventory and reducing inventory, by itself is not very valuable. It's only in the context of a total system of delivering value to the customer. And the way you deliver value to the customer is through processes. And often we think of processes as something to implement, like I implement Kanban, I implement standard work, I implement visual management, whereas Toyota views them more as dependent variables, something to try to achieve. So I want to achieve delivery to the customer one piece at a time without waste. I want to, in order to do that, I need to create a situation where people are following the best known way of doing the work. And standard work is the way we document what we want the worker to be doing. And to get people to follow standard work, to do their best, and to continually improve, because every year you have a higher and higher goal, they need to invest in people, make them feel like, actually treat them genuinely as team members, not as disposable labor. And a lot of the training that's done is training in what Toyota calls problem solving, which is working scientifically toward a challenge. So at the center of all this is scientific thinking. If you haven't developed people to think scientifically, none of these other pieces will actually work in practice. Okay, so what is scientific thinking? And I got this from Mike, and Mike and I have been buddies for a while, probably interacting more since we've been talking about and learning about Toyota Kata than maybe we even did when he was at the University of Michigan as a student. And the first thing about scientific thinking is that we don't know what we think we know. We have some representation of reality in our brains that's very incomplete. And we tend to think it is reality. And we have to acknowledge we don't know anything. So for example, the first lesson, if you were to go to Teiichi Ono, the creator of the Toyota production system, was to stand in a circle for the entire day in one place in the factory and just look. And he would keep on asking you, challenge you to think some more about what you're thinking. And what he was trying to do is to get you to go below the surface of your first impressions and really look deeply and understand what was happening. The second point is that assume that our ideas for how to solve a problem are only ideas, and they may not work the way we think we're going to work. So we need to test our ideas in some way, not just theorize. So there's a lot of value in Toyota placed on learning by doing, not just learning by debating, analyzing data, theorizing about what might happen if we try this. And then finally, appreciating learning from differences between what we predict and what actually happens. And this can be very difficult for humans. And we have a natural tendency to want to be right. And in fact, we will fight really hard to defend what we think is true. And what this is saying is a good scientific thinking means that if I predict something will happen and something different happens, I find that really interesting. It doesn't mean I'm dumb or I'm bad at my job. It means that the world is full of uncertainty. And one person said that the best single symbol to illustrate scientific thinking is a question mark. So it's a outlook of questioning and wondering what will happen, and then being interested to see what will happen. So I put this into the center of my model, and I still have 14 principles. Some of the principles are similar to what I had in the first book, for example, but they've been modified a bit. Like philosophy, I put the word systems thinking into the principle about philosophy, and I wasn't emphasizing it, I don't think, enough. And the system thinking is both the parts of the system, say inside an operation, like just in time. Part of that system is just in time working together with building in quality and stopping when there's a problem and working to stabilize processes. And then more broadly, recognizing that you live in a world and you affect the community, and you have to understand what customers want. You have to understand trends in technology. And so there's a broader view of your impact on the world and the global community. And then processes haven't changed all that much but I've emphasized again in the processes that they're not something to implement, but rather something to strive for. Then for people, I've emphasized more developing people in scientific thinking. And Toyota's way of doing that is to sort of push you into the deep end of the pool and allow you to struggle with a coach watching you and giving you guidance. But the deep end of the pool is usually a challenge that at first seems impossible. Like improve productivity by 80%. And you have no idea how you could possibly do it. And then you start working at it, and they're guiding you mostly through questions and sometimes grunts and moans to let you know if you're off track. And lo and behold, maybe you didn't get to 80%, but you got to 78%. And then you still feel really bad because you didn't get to 80%. So what they're trying to teach is the fourth part, problem solving. And I've revised that the most. So 12 really deals with what Mike will talk about with the Kata, but it's really learning to observe deeply and learn iteratively, step by step toward the goal. Having a clear picture of your goals through aligned goals, and I talked about Hoshin-Conry, this method of deploying goals from the president of the company to everybody who's working in the company. And I've added a discussion of connecting this to your strategy for your product and your business model, and then connecting that to your execution. So I mentioned that lean processes are something to struggle toward, not something to implement. And in fact, mostly what makes the Toyota production system different than traditional manufacturing is that Toyota is trying to simplify and allow you to visualize the process. So for example, the idea of a pull system is that we make only what the customer needs, our next customer needs, and the model used for that originally was like selling milk in a grocery store, where you put out a certain amount of milk, the customer takes away milk, and then you replace what the customer takes away. The Kanban is ordering, I now want a new unit of milk because the customer has taken away a unit of milk. So the Kanban system has become very popular, and it's visual and it's cool looking because you're, instead of schedules and computers, you're controlling production based on cards circulating around or some sort of signal. But the real purpose of Kanban was to make problems visible. So if I have a system where I have a card on a container, and then I move that container, and then when I start to use it, I take the card off, and I notice there's a card sitting in inventory that doesn't, a container sitting in inventory that doesn't have a card, I know there's a problem. If the customer is running out and a container is supposed to be coming, but it doesn't come, I know there's a problem. So this is making problems visible so that we could then solve the problems. And there's a lot of encouragement in Toyota to just try it. I don't know whether I should have 5 containers circulating or 4 containers or 3 containers. They might say, well, try 5. And if you've got 2 extra sitting in inventory not moving, then take 1 away and see what happens. A lot of emphasis on trial and error, but based on actual experience. And then the tools are simple tools to visualize. Here's what's happening. Here's where there's gaps and problems. When I try this, I can see what's happening, what the result is. And this is through Plan, Do, Check, Act, again, continuous improvement. And this was, it's given credit to Dr. Deming, who taught quality control, but it became a more general way of thinking, which is not just one big Plan, Do, Check, Act, where you plan a new technology, you implement the new technology, you check to confirm it works, and then you take further action based on what you learn, but rather you have a goal of achieving something with the new technology, and then you break that process of developing and introducing it into smaller steps. And from each step, you're doing Plan, Do, Check, Act, and running experiments and testing your ideas. So it becomes a wheel that's moving quickly, and you're constantly running experiments. So this is all good and well, and it makes sense. And I certainly, people in engineering are not going to argue against scientific thinking, and probably not argue against long-term thinking. But it turns out it's really difficult for us, not us non-engineers, but for us humans. We're not good at it. And the problem is that our brains, going back to primitive times and Darwinian survival of the fittest, were really designed for quick action and quick results to survive in the jungle. And we needed to know, not guess. And we needed to feel we were certain just to stay alive. Another problem is that our brain takes in a whole lot of information, but we can process only a tiny percentage of it at a time. So we can take in 11 million bits of information a second. We process 40 to 50 bits of information a second. So how do you deal with that tremendous loss of information? And that is to use existing frameworks, categories, to take the 40, 50 bits of information and try to generalize it to the 11 million bits. And we do that through various kinds of shortcuts, which are called biases. And in psychology and behavioral economics, they've documented hundreds of these biases. One, for example, is confirmation bias, which is that when we have made a decision or committed to a course of action, we will tend to only look for evidence to support that we were right, both before we take the action and after we take the action. And if you criticize me and because it didn't work right, I'll argue with you, I'll defend myself, and I'll become even more locked in to my prior belief. Again, this is just one of many biases, but it prevents us from thinking scientifically. So our tendency is to just want to do stuff that we are confident is right and not test our ideas, not do much planning, not learn from our experiments. So this is the model Mike developed that he'll be talking more about. And in some ways, it's very simple. There's 4 high-level steps. One is you have to know where you're trying to get to. So the direction or challenge needs to be clear. It's surprising how often that's not clear. And people are just doing stuff, like in Lean, they're implementing Kanban, implementing standards work, they're doing 5S and cleaning up the workplace, but they don't know why they're doing it or what they're trying to accomplish. This is intended to be a big challenge, a stretch beyond what you think is possible today. Then you start to understand the current condition. By start, I mean the current condition is something dynamic and changing all the time. So you don't want to spend a huge amount of time collecting all sorts of data, analyzing all sorts of data. As I mentioned, I taught At the time, it was IOE 591. It was a new course, and I called it Lean Thinking. And I used this model. And a natural tendency of my very bright master students was to want to collect statistical data and analyze the heck out of it. And I had to stop them and say, enough. You have a great understanding of everything that might have happened in the past. But what we're trying to do is move forward. What is your target condition? What are you trying to accomplish this semester? Will it be a successful outcome? And then start trying things, start experimenting. And once they started experimenting, then they didn't want to stop experimenting. And then the challenge was that we talk about the experiment, not in real formal terms like design of experiments, but rather at least understand what you're testing and what you think will happen when you test your idea. Then after running the test, reflect back, look at data to see what happened, and then finally ask yourself, what did I really learn from this? So once the students got involved in experimenting, they would tend to forget to predict what was going to happen and to reflect on what was going to happen, and they wanted to run the next experiment. So I found that it was actually quite challenging to teach these smart scientific thinking students this way of scientific thinking, but they got a lot out of it. The course evaluation is really good, and the students felt like they had really changed their mindset in some important ways. Okay, so this is what we call iterative learning. So instead of trying to jump to the challenge with one big idea, you're learning your way iteratively by trying a lot of ideas and learning from each experiment. And I've been kind of pushing what's on the right here, this adaptiveness model of Lean, that Lean is about adapting to change, testing hypotheses, learning by doing, wondering what's going to happen. But the way Lean is often implemented is much more mechanistically. Here's my plan for Lean deployment. Here's the tools of Lean that I'm going to roll out as quickly as possible, get quick measurable results. And there's a feeling that I know what's going to happen when I implement these tools because I've done it before. This should work. In a lot of discussions with Mike, we came to the conclusion this is more like the yin and the yang, and that there are some things that are within your threshold of knowledge that you can implement maybe relatively quickly. What's going to usually happen if I say take a week and do a Kaizen workshop and change a bunch of things is that I'll get some positive results, but I'll also destabilize the process. There'll be things people don't know how to use. They don't know how to follow the standard work. And in following that, they'll need to adapt and learn through experimentation. Excuse me. So these things actually can go hand in hand, where sometimes you're implementing something known and sometimes you're experimenting.